Dear students, welcome to the third week of our offshore production engineering course. Let me continue with the schedule for the third week. In the first and second weeks, we mentioned about the introduction and the information of the course, and then the historical background and the background to geology and reservoir of oil and gas, which is very crucial for the offshore environments as well. So now in this week we will mention about the details of the offshore oil and gas operations like exploration, production and transportation, how we are doing this operation-wise. We will mention the details of all of these, all right? So, and the week 4 we will continue with ocean environment and sea space. We will go some more deep into the details, all right? So let's continue. Okay, for the offshore oil and gas operations, we can say that oil and gas operations cover a kind of vast spectrum of activities that starting with the establishment of the existence of this natural resource in the mother of earth up to utilizing it in the best possible way. Okay, so these operations, when carried out in an offshore environment, they are called offshore oil and gas operations. So the operations begin with the geologists and the geophysicists hunting the possible oil and gas reserves in the bearing stratas under the ground in onshore and below the ocean bed in offshore, and ends with the transportation of the oil and gas from the source to its destination. Or in the case of offshore, from the offshore site to the shore location, actually. All right. So these operations can be broadly divided mainly into 4 different groups, 4 main areas. These are exploration, drilling, production, and transportation. Okay, so 4 categories. Don't forget these. These are exploration phase, drilling phase, production phase, and transportation phase. Okay. Okay. Let's. So first of all, exploration. So exploring or prospecting for hydrocarbons is a kind of integrated process which involves the geology, the geophysics of the structure, all right, and the fluids as well, and geochemistry with the objective of finding a structure suitable for storing an economically sufficient quantity of hydrocarbons, okay, for oil and gas, of course, all right. So on land, for example, sometimes shallow in-situ testing is used in conjunction with geophysical work, whereas offshore prospecting almost always relies on the geophysical method. Primarily, we call it the seismic method. Okay, seismic method. Don't forget. All right. So for the exploration, the main mechanism that we have to focus on is the seismic methods. All right. Okay. So. One of the methods, we can say, the geological methodology, all right? So geology is the science of rocks, right? We all know all of these. All of us know about this. The geologists carried out a survey either at the ground surface aerially or through satellites with the aim to identify the formations, study the stratigraphy, the sedimentology, and the structures like faulting, and so on, all right? So for establishing the geometry of the structures, the core samples are also drilled out, okay, in certain depths. Core samples also carried out from downhole to the surface and then taken to the laboratory for some analysis, all right? So in offshore, when an area is found to be favorable from geophysical studies, actually, okay, so coring is done for core drilling ships, okay, by using the core drilling ships, the coring operations done, okay, that special ships are used to do these operations. So these specialized ships can remain dynamically positioned on the location and drill in seas with nearly 9 meters, 30 feet, let's say, waves, and in depths approaching to 4,000 feet, nearly 1,200 meters. They are able to get the core samples from, all right? So we have to be careful about that. These are very important. So cores are taken from the ships separate ships are used for this one. All right. Okay. Another one is the geophysical method. The different geophysical methods that can be applied to oil and gas exploration are gravimetric, magnetic, electromagnetic, and resistivity, we know it as resistivity from the lab courses, electrical, yeah, I mean electrical, and the seismic, out of which the seismic method is the most commonly used in the oil and gas exploration, actually. All right. So it is based on the principle of the propagation of seismic waves underground or under the ocean bed. Okay. So a seismic survey is a kind of program for mapping the geological structures by creating seismic waves and observing the arrival time by the waves reflected from the acoustic impedance contrasts or reflected through the high velocity layers. Okay, so you can see it by in the picture, in the figure it can be seen. The ship is sending the sound wave source from a sound wave source. Sound waves are sent. It reaches to the seabed and passes seabed through to the ground also. Okay, through to the rock layers, and then it reflected from each rock layer differently. Okay, because the density of each rock layer is different, and then these reflections are recorded by the hydrophones which are following the ship. Okay, in the background of the ship, in the backyard of the ship. It follows the ship with a cable, and then these hydrophones recorded the waves that's reflected from the rock layers, and according to the depth, it can describe what type of rock type or fluid type, including these layers. All right. Okay. So there are two types of seismics. We can say one of them is the seismic refraction, and the other one is the seismic reflection. Okay. So for the seismic refraction, this method is essentially used for the shallow investigations. Sometimes it's applied as a resonance tool in the petroleum exploration. You can find sometimes in the onshore as well. So seismic reflection is used as a day-to-day exploration tool to map the shallow as well as deep subsurface geologic structures. Okay. All right. So for the geophysical method, we can say in most cases the seismic reflection technique is used extensively for hydrocarbon exploration to map the subsurface structures suitable for oil and gas entrapment in the sedimentary basin in onshore and offshore areas. So seismic exploration consists of three stages of operation. What are these? These are the data acquisition in first case, data processing, data interpretation. Okay, so these are the stages of the operation. Okay, seismic data acquisition begins with, of course, with a seismic source that creates the seismic waves and ends with recording of echoes from the beneath surface that result from the source disturbance we already mentioned. Okay, so there are several techniques for generating artificial seismic waves. The most common are the chemical explosives such as dynamite, mechanical vibrators called vibrator trucks, and compressed air guns. Okay, you can see examples of these. There are the same gun in compressed and decompressed position. Okay, in the compressed position, you can see in the port there is a squeezed part. You can see when firing the piston, so it changes to the compressed position. All right, so we call it the compressed air gun. Okay. So we are using in the subsea. These are used in the subsea. So the Earth's motion is detected by the transducer called the geophone on land and by pressure detector called the hydrophone at sea. Okay, we mentioned already. So hydrophones are pressure detectors that are sensitive to any kind of variation in pressure. So normally hydrophones are kept in few feet below the water surface in marine operations. And the piezoelectric and the magnetostriction types are common, all right, in hydrophone, we can say, in the structure, inside structure. So the sensing element in piezoelectric crystals is barium titanate and the lead zirconate, all right. So these are good piezoelectric materials, and they are using these two materials in this tools in hydrophones, all right. All right, so from the detectors, that is geophones and hydrophones, the signal is transmitted either by a cable or by telemetry to a seismic recording unit, where the signals are combined and recorded on magnetic tape. Okay, you can see it in the figure. So for modern seismic data is acquired by the digital recorders capable of recording the entire seismic signal encountered in oil exploration. So the most common feature of any digital recorder called digital seismograph, right, is the dynamic range of the system, which is the ratio of the largest recoverable signal for a given distortion level. So to the distortion level to the smallest recoverable signal, all right? So the smallest recoverable signal is often taken as the noise level of the system, right? So when you see the noise level with a value, with a certain value, you can see that this is the smallest recoverable value, right? Okay. So before the digital recording, the signals pass through an analog to digital converter, right? The graph that records geophone hydrophone vibration is commonly called a trace. Trace, okay? Don't forget this trace. So the dynamic range of any system is expressed in decibels as the following formula. As you can see here, the dB equals to 20 times log 10 A divided by B. Here A and B are the largest and smallest recoverable signal, and the ratio of these two and the log of this, when you take you multiply by 20, it gives you the decibel, all right? Decibel, all right? You know decibel, what decibel is. So the definition comes here as a scientifically with this formula, all right? Okay, so the hydrophones are recording in decibels like this. So for marine operations, as you can see in the figure, for a seismic ship is going with the hydrophones, okay, and with an air gun in the backyard of that. So in these marine operations, seismic operations, the digital streamers of nearly 240 channels capacity are used, okay, nearly 240 channels, different channels. Channel capacity is used as this. And due to the fast technological advances, of course, these new seismic recording systems are now available for data acquisition to overcome some existing problems and can be used in difficult areas, right? So until very recently, the most seismic data acquisition campaigns were processed in two dimensions. We call two-dimension campaigns, all right? And it was not until 1972 when, with the advent of the new technology and powerful computers capable of processing and interpreting the data in three dimensions. So 3D data acquisition became more widespread, of course, by time. And today, 3D seismic campaigns are very popular because of the following some advantages over the 2D techniques, actually, right? Uh, So what are these advantages? When planning a 3D seismic campaign, it's important that the geometry shots and receivers record the seismic signals with the widest range possible and the minimum amount of the noise and distortion. So as you can see, the 3D mapping style and 2D mapping style and 3D mapping style in here. So 3D mapping style gives you a kind of accurate trace positioning, improved velocity control, about half kilometer grid. Okay, if you divide it in grids, half kilometer each. So improved velocity control is possible. Improved signal to noise ratio is possible compared to 2D. Data redundancy, cost effective compared to 2D because you are describing certain depth in here, and you have to do with different depths. You have to run your operation time much more times compared to 3D. So 3D once you do it, you can do the modeling directly. So accurate well location description is available. Accurate reserve estimation is much more possible compared to the 2D, and improved drilling success ratio also is succeed compared with the 2D, much more succeed, and the ratio is higher than the 2D version. Okay, so in most of the operations, nearly more than 90% of that, this 3D type of seismic has been performed. Of course, some price differences, but now 3D is the most common. Okay, the type of the processing is mainly controlled by the particular software, all right? So in the seismic data processing. So whereas the actual execution, the size of the processed data and the speed of the computation are mainly governed by the system hardware. That is the computing equipment we call. Okay. So referring to the block diagram, the observational data, which are records made in the field, acts as an input to the processing system, and the seismic stacked sections representing as truly and clearly as possible the subsurface geology of the area that acts as the output actually. So the input may be raw data either for 2D and 3D needs, suitable processing sequences to produce a stacked section. Okay. So observational data, processing system, and the useful information is gathered by using this three-step process. All right. Okay, so I'm moving from this one to the data interpretation part. You are seeing here a kind of real seismic data. Okay, and the geophysicists with the help of the geologists, they are making some kind of interpretation on this. So the interpretation of the seismic data in geological terms is the objective and final product of the seismic exploration with the purpose of locating structures which provide the excellent traps containing commercial quantities of oil and gas. Okay, so the main idea to do that is to identify the traps. Okay, traps. So here, as you can see, there are some trap anticline sections can be seen clearly, anticlinal structures. So some of them has a kind of potential to include some oil or gas. All right. So, however, many such structural traps do not contain the oil and gas in economic quantities. All right. So, since the drilling of an oil and gas well is very costly, the effort is made to derive the maximum information about the geological history of the area and about the nature of the rocks in an effect to form an opinion about the probability of encountering the petroleum in that structure. So, for example, in a certain depth, in this example, for example, in a certain depth, you saw a kind of anticlinal. So there is a potential. Maybe you will drill your well according to this, and you are passing the geological zones, okay, geological lithology, and you're gathering, reaching to a certain depth. Maybe you could not find something economical in here, and then you have to drill more. In that case, to if there is another, or maybe in a cross-sectional part, in maybe some cross-sectional part, maybe eastern part to the north part, you will see some more anticline structures. So maybe you can deviate your wells if these are not found to be economical to be produced. So you can make some deviation to reach to some more anticlines in lower structures. So according to your drilling plan, simultaneously you can change it and you can make certain decisions according to the scenario coming to your way, of course. Okay. So seismic data are usually interpreted by the geophysicists or geologists. Both of them can be responsible with a strong background of the data acquisition and data processing operations. Okay. So the object of the seismic interpretation is usually to prepare two-way reflection time contours. All right, isochron they call isochron. All right, contours and contour maps. Of course, we say contour maps showing the depth to a series of reflectors which have been picked on the stacked seismic sections. So to carry out this process in a seismic survey in offshore, a ship equipped with all of the above facilities on board, known as a seismic vessel, is deployed. Okay. Okay, so let's go on. So another one is the geochemical method. All right, so you can see some a kind of geochemical map in here. All right, distribution to PB in the 0.18 millimeter soil grain size fractions. It says in this method, actually, the aim is to find the traces of hydrocarbons in the air and in the soil. So as a result of their migration to the surface through a system of fractures, when hydrocarbons migrate to the surface, okay, they leave some type of traces of hydrocarbons in the soil. So when properly analyzed from the geochemical point of view, called spectrography of the heavy components from C15 to C30, okay, so you are familiar with these ones, I assume that. C7 up to C7, C1 is starting from CH4 methane, and then ethane. Okay, so according to that, it goes from C1 to C7 and C7 plus C15, C16 up to C36, right? So these are the chains, hydrocarbon chains we are talking about. So spectrography of the heavy components starting from the C15 to C30, all right, the type and degree of the maturation of the hydrocarbons become known, okay? So when samples are collected in the depth near the source rock, it is also possible to assess the type and degree of the maturation with the help of the petrographic analysis, reflectivity of organic compounds such as, for example, vitrinite, which is one of them, okay? So there are these reflectivity, so you are making some petrographic analysis, all right? And then you make your description regarding on the hydrocarbon chains and the value of these hydrocarbons as well, right? So when the geochemical and the petrographic studies are properly integrated with migration models, conceptual models can be drawn up to origin of oil and its type and its degree of the maturation and the migration of the hydrocarbon. The second one that will focus after the exploration is the drilling process in offshore. So once the indication is received from the geologists and the geophysicists regarding on the seismic data and some sort of variable data that we can evaluate, after the evaluation, the geologists and geophysicists gives you the report and you start to evaluate the indication of these reports. So about the existing of the hydrocarbon bearing structures within an economic range to validate their conceptual model, and exploratory wells needed to be drilled to provide confirmatory evidence about the presence of oil and gas and their commerciality. Okay. Thus, what happens, to discuss briefly the drilling, discuss in detail in a later chapter. We will talk about this in next weeks. Okay. So depending on the purpose and the timing, it can be broadly divided into two different types. What are these? One of them is the exploratory drilling and the development drilling. Two main categories, we are separating them. Okay. I can ask these ones in the exam. So exploratory drilling and the development drilling part, right? For the offshore drilling. So the type of the processing is mainly controlled by the particular software, all right? What's going on herein actually, whereas the actual execution, the size of the process data and the speed of the computation are mainly governed by the system hardware, that is the computing equipment, okay? Referring to the block diagram, they transfer it, and the observational data, which are records made in the field, acts as an input to the processing system, and the seismic stacked sections representing as truly and clearly as possible, okay, clearly as possible, the subsurface geology of the area act as the output data. So the input may be raw data, either 2D or 3D, needs suitable processing sequences to produce a stacked section actually, okay? So by using these ones in the drilling, you make your decisions based on these data actually, right? So in the exploratory drilling, the first one, we can say that to confirm or deny the presence of the hydrocarbons, exploratory wells are drilled. Okay, so this is the first well drilled in an unknown structure, so exploratory, right? So it is sometimes called a wildcat well. Wildcat well. Okay, if you see wildcat, so it means that it's the first well that drilled in an unknown structure. You don't have any idea regarding on the geological structure, the lithology, the rock types, including in there, in which rock type you can find the reservoir, all right? So in which depth, you don't have any idea regarding on the location, okay? So it's a wildcat well, all right? So during such drilling, a lot of information is gathered regarding different formations encountered with the depth, and simultaneously logging, coring, testing, and so on are also done. Okay, so these data or information help in studying the commercial viability of the new field. After that, you start to give a kind of description regarding on the economic value of your offshore field. Okay, if you describe it, of your offshore potential, the volumes, okay, of oil and gas in the field, and you start to give some forecasts regarding on what type of value it has in it and how many years it takes to be produced. All right. So a few exploratory wells, other than the wildcat wells, are drilled to delineate the reservoir boundary, which helps planning what for future development of the field in most economical way, so that the life of the field can be expanded. Okay. So in first case, you make some wildcat wells, and then you have a rough idea. You evaluate this. You can see that there is a potential in here, so we have to focus on that. Let's drill more. Okay. When you decide to drill more, you describe the new locations of the exploration wells. Okay, and then you focus to it, and of course, how many wells you drill more, you get a much more idea. And then, of course, with the production, you can make your production monitoring and management well. And of course, this resulted in having a kind of expansion on the life of your field, right? Your offshore field. So since the investment made in a drilling a single well is very high, we already know this one, it is a matter of concern for the investor or the owner. So you have to describe certainly what is the economical value in below, right, in reservoirs of that area. You have to describe the economical value, and it's worth to drill more or not. So you have to describe this one. Okay. So you have to, if you're a responsible person in a company making, for example, service company or whatever, you have to convince your investor or the owner regarding on this. First, of course, you have to describe the value, and then you need to convince the economical investor of this project, actually. Okay. So as far as the onshore exploratory wells are concerned, the decisions do not depend much on the type of the equipment except their capacities, but in offshore, the deployment of the type of the platform is to be made judiciously, actually, right? Judiciously it has to be made. So here is not advisable to deploy a fixed platform, because in the case of the non-commerciality, the platform has to be abandoned. Okay. So therefore, what happens in that type of case, in that scenario, it has to be the mobile units that needs to be used like a jackup rig or submersible unit for floating units. So in the wildcats, so you have to use. It's better to use what the ships, for example, drilling ships, offshore drilling ships, and some semi-submersible or jackup rigs. Okay, so this is very crucial. To make it much more economical, actually, because you will invest the money and you have to make a kind of cost reduction in first cases before describing the potential of your field, actually. Okay, so it has to be some floating units, semi-submersible or drill ship is the best option in these wildcats, actually. So even if no commercial hydrocarbon is found, these mobile units, what happens, can be shifted to some other drilling site and used in there for much more possible reserves, maybe. All right. Okay, so very good. Let's go from the exploration drilling. I am passing to the development drilling part. Okay, the development drilling part. So once the results from the exploratory wells are positive, then a detailed development planning is done so that the exploitation is made in the most profitable way. Okay, so I made my wildcat wells, and then I said that, okay, I'm seeing some type of potential in here, let's drill more. So you made some exploration, okay, some exploration wells, and then you get some more data by using your testing and wireline results, all right, logging and testing results. And then you evaluate more, and you are seeing that, okay, so you are making some FDP called field development planning. After that, so you can say that, okay, this we will continue with this one because it's much more profitable. We are seeing a potential in here for next periods. It has a potential to produce 20 years, 25 years, 30 years, whatever. All right. So you describe and you decide or to continue or not continue. Okay. So the most important is to mark the position of the development wells here on the structural map, and this depends on whether it is in onshore or offshore it will be. Okay, in some parts, for example, if you are close to the shoreline, all right, So maybe going with the onshore well and making some deviation is much more cost-wise. It's much more economical compared with the offshore one. Okay, but it is a huge structure you are seeing beneath. Then maybe offshore can be much more in long-term period. It can be much more economical compared to onshore. So you have to describe this type of ideas, all right? You have to discuss, you have to put your values, you have to put your clues for the future forecasts as well, all right? So you have to decide according to this, okay? Well, the most important is to mark the position of the development. That's what I want to say. On the what? On the structural map, and this depends on whether it is in onshore or offshore. This is the way that we have to decide first of all. And in offshore, generally development drilling is done from a fixed platform, preferably self-contained, from where many wells are drilled to reach the different locations in the reservoir by using the method of directional drilling. Okay. So this form of drilling has the advantage of having the flow from many wells converge to one surface location for production. So every self-contained platform can permit drilling a minimum of 8 to 10 wells with the directional, okay, giving some variations, so giving some deviation as well. So you are capable to drill 8 to 10 wells from one platform actually. So there are other types of fixed platforms also, which are also used for development drilling. Details of which are will be discussed in next weeks. We will talk about this. All right. Okay. So after the drilling part, I want to come through to the our main topic, the production, offshore production one. Of course, the next week will be related to directly to production, but in this week I will give some little details regarding on this. But let's continue. So immediately after the development drilling, during which different casings are lowered to reach up to the target formation, production tubing is lowered from the surface, which becomes the main communication path for the well fluid to flow up to the surface. Okay. So before starting actual production of the well fluid, which is nothing but a mix of oil, gas, and water, the well needs to be completed in all respects, which is known as well completion. Okay. So your completion is very crucial to describe what type of production you will have in the future. Okay. What type of forecast you will have. Okay. So this is very crucial. So your completion has to be done with professional crews, professional people, especially if you are dealing with a kind of exploration location, exploration field, all right, and potential reserves. You are guessing that there's a reserve in there, but you have to be sure about that. So you have to work as much as professional people. All right, this is a very important one. So basically, it consists of certain operations like perforation is a part of that. Setting the packers is a part of that. Installing a Christmas tree in the surface at the top of the wellhead, and so on. The details of which are covered in the subsequent chapters. We will mention about these in the next weeks in details. But these are the very crucial parameters that's affecting your production. Okay. So in offshore, depending on the whether the Christmas tree is placed above the water or water surface or below, these are the termed deck level completion or subsea completion it will be. So you have to decide to this one, okay, in which part you will use this Christmas tree, okay. In here it will be, or in here it will be. In which conditions we have to use it in the above sea level? In which conditions we will use it in the seabed? All right. So we will discuss all of these, okay, in the next weeks. So, broadly speaking, the production operations that are carried out during the production life of a well can have two broad divisions. So one of them is the downhole operations and the surface operations, as like what? Like the onshore stages, okay? Like the onshore operations. So those operations that are carried out through the wellbore during its producing history, like workover operations, wireline operations, stimulation operations, artificial lifting, and so on. So fall under the first category, whereas those operations that are carried out at the surface, like separation treatments, storage and transport, are commonly termed surface operations. Okay. So as far as the downhole operations are concerned, there is no difference between onshore and offshore in here, so long it's the deck level completed, but in the case of the subsea completed wells, a conduit from the subsea well up to the deck of a floater is necessary. All right. So of course, some more details we have in offshore, but the structure is nearly same compared with the onshore structures. Okay, so we are dealing with the downhole and the surface. You have some equipments which are transformed to the offshore versions. Okay, the tools transformed to the offshore versions compared with the onshore. Okay, for example, if you are dealing with a multi-phase flow meter in the surface, let's give an example with a new technology material. So if you are dealing with a multi-phase flow meter in the surface operation, so the subsea version of it is totally different compared with the phase tester, for example, Schellenberger's phase tester, which they are using in the surface, in the onshore. Totally different structure it has, and it's much more closed loop structure it has. Okay, closed loop structure. So you cannot make any maintenance from the outside directly. It's all complicated and closed section it has. All parts are closed, so the specialized people has to be come to the offshore platform, and if there's a fix needed, then they are doing it in place according to that. Like closed engines you see in the cars, for example, in the latest cars, latest technology with technological developments, some cars are their engines are in closed, okay, closed loop they have. All right, so you cannot open it very easily, okay, like that. The tools in the offshore environment is also has these closed loops in some part of that we will mention in next chapters. Okay. Okay, so when the surface operations, which are mainly processing of well fluid, are to be carried out, the arrangement is totally different in the case of offshore as compared to onshore. True, conceptually they are similar. We already mentioned. So here many wells are completed in a single platform. If deck level is completed, these platforms are called the well platforms, which normally house 48 wells, and they are normally unmanned. Okay, so that is, there is no provision for living quarters for in the working personnel and these type of things. There is nothing like that. Okay, there is no human in these platforms, and they are producing. Okay, and maybe in 8 to 10, 48 wells are combined in a station, and then production continues through to the. They send the oil and gas through to the shoreline if there's a facility in there, and directly the fluids go through to the facility from these stations. Okay. So throughout the offshore field, actually, many such well platforms are visible. You can see there is one example in the Black Sea we have in Akçakoca region. All right. So I had a small visit, one day of visit I had done to these wells. In 2005 it was 2006. So they are similar like this. Okay. So you cannot see the you can see just the platform, and there is no human on that. All mechanical, and now I am sure that they transform it to digital. It's controlled by the machines directly, and then it produces and send it through to the stations, and from the stations direct send it to the shoreline, through to the facility for making the necessary separations, okay, of oil and gas and water. So, as you mentioned, throughout the offshore field, many such wells platforms are visible, we said. Okay, so from such well platforms, well fluids flow to a large self-contained platform known as the process platforms, which are multi-decked and have separators needed for separation of the well fluids into oil, gas, and water. In some cases, it's separate. Okay, treatment facilities. For example, if the shoreline is too long, okay, 60 kilometers, 70 kilometers, so you need to separate it in the offshore environment, because when you are transferring it through the pipeline from the seabed, there can be some problems because your mixture, okay, you have gas in it, you have oil and water, and there's a mixture of that, and some change in the temperature and pressure can lead some problems, or gas hydrate forming can be happen. So because of that, you are making, in some cases, you are making the separation in the offshore line, okay, in the offshore environment directly, and then you separate it, and from different lines, the separated materials, the fluids, comes through to the shoreline, okay, transferred to the shoreline. Actually, this is happening, okay. So the treatment facilities for oil, gas, and water, and storage, not very large, but these storage are limited storage facility for storing oil flares, for burning gas, auxiliary equipment like pumps, compressors, and power generators. Also use material handling equipments like cranes and so on, safety devices, telecommunication devices, and other devices are used in these actually. Okay. So what we can say more than this, in some of them also they are able to they are available to be used by helipads. Okay, helicopter can be down, all right, can land on some of the platforms, one of these, especially if they're in the open sea, in the oceans. Okay, so these type of things, these type of structures can be seen, all right. Okay, so in deep waters, instead of a fixed process platform, a floating production system called FPS is used, where mostly floater ships are used, whose decks consist of all the surface facilities required for separation, treatment, and so on. Okay, so including the facilities for living quarters, safety devices, utilities, and other auxiliary support systems. So sometimes the hull of these ships is used for storage of oil and contains facilities for offloading the crude as well. Okay, so in such cases they are termed floating production storage and offloading, called FPSO. Like floating production system, we call FPS, and then when you set production storage and offloading, FPSO, okay, production storage and offloading. So these FPSs are receiving the well fluid from the subsurface, subsea, complete well through the different production risers, which are flexible pipes of different configurations and sizes. For offloading also, other risers are used, which are commonly termed export risers as well, right? So an elaborate discussion on this have been made in subsequently we will mention all of these in the next weeks, okay? We will mention. Okay. So fourth one that we have to focus on is the transportation part. After the production phase, this is the issue: how I will transport these fluids, sorry, from the location, produced location, subsea location, through to the shore or land. All right. So whenever the transportation is talked about in the oil and gas industry, it either refers to liquid and gas transportation or worker transportation as well. Okay, so the crew transportation, because these crews are working, in shift ways. Okay, in the shift, and then these shifts being probably being 4 weeks, in every 4 weeks, in every 3 weeks, sometimes 5 weeks. In Schlumberger, when I was in Schlumberger, we were working in 7 weeks to 3 weeks, for example, 7 weeks on, 3 weeks off. So these type of structures, working schedules, can be seen. So there is a transportation needed to transfer these crews from land through to the offshore, land from to the offshore, or offshore from offshore to the land. Okay, so because of that, is another issue: the transportation of the workers. So transportation of the fluids and the transportation of the workers, two main things we have to focus on in transportation stage. So for liquid and gas transportation, it starts from the well itself. Okay. So referring to the offshore, each well platform is connected to a process platform by production risers and the flow line that carries the well fluid. So from the process platform, the separated oil and gas separately move through individual pipelines, either to the shore or any storage device. So sometimes ships are also used to transport the separated oil in the absence of any underwater pipeline. Okay. So the flow lines, the risers, ships, or barges are the major modes of the transportation in the first case. Okay, that's what we can say. So in the second case, the worker transportation from shore to platform or from one platform to the other is accomplished either by boats or helicopters according to the situation. So if you are working in the North Sea, for example, a harsh condition, harsh environment, so most probably you have to transport people by using the helicopters instead of boats because of the climate conditions, and sometimes it can be rough because of the waves and the stormy weather, whatever. So you have to select, of course, according to the status and situation, right? So high-speed crew boats transport work crews when time is available and the distance is less than about 50 miles, 80 kilometers. If your offshore environment is less than 80 kilometers to the shoreline, then you can transfer it by using boats. So helicopters transport crews and other personnel over long distances and when time is important, actually. Okay. So simultaneously to the worker transportation, materials, consumables, non-consumables, and equipment transportation is also accomplished with the work boats. Okay, so for example, there can be some samples taken from the downhole. There can be some fluid samples taken from the wellhead. Okay, so you have to make analysis in the laboratory, core samples, for example. So you have to send them to the laboratory rapidly. So in this case, what needs to be done? There are work boats, and by using these work boats, you transfer it. Sometimes helicopters are not suitable. For example, there can be some H2S amounts. If the H2S amount is above 5%, you cannot put it to any flying objects. Okay, like helicopters, planes, whatever. So because of that, the shipment by using the boats, doing it by using the boats is the best way, right? So these boats are generally about what happens. It's about 9 meter 30 feet the length. Sorry, it's about their length is about 43 feet. It's around 43 meters. It's around 140 feet, and it's about 9 meter wide with 30 feet. We can say. Okay, so it's a big ships actually. Big boats we can say. So they are versatile and high-powered and essential to offshore operations. These are sometimes referred to offshore supply vessels. They include also OSV, offshore supply vessels. Thus, what we can say, all fixed platforms where boats are to anchor must be provided with mooring bits, bumpers, cranes, stairs, and so on. They include to be transformed or to be transported. Okay. So these are the main things that I can mention for the week 3. All right. Now we focused on the exploration, drilling, production, and transportation stages. We didn't go into details, but gave some ideas, rough ideas regarding on how they are doing, what are the main components and how we are doing, and the processes about them. All right. Now we start to focus on the production stage. Okay, start from next week. We will much more focus on the production stage, and week by week we will go into details for offshore production. Okay, so these are the things that I will mention for this week actually. If you have any questions, I will glad to answer. Please write them, and I will answer them. Okay. So meanwhile, if you have any questions within this week, about this week and the previous weeks, you can also write to me. You can send via my mail. I can give you my mail address. All right. You can directly connect with me with this mail address, and we have WhatsApp group. You can write them also by using the WhatsApp group as well. Okay. So these are all things that I will mention for the week 3. So see you next week all right. Thank you. Cheers.